Hello, my name is Jennifer Winkleman, and I'm going to be doing this Math 111 Test 2 review. I will be breaking this up into chunks and posting this on YouTube. I have also posted the review, and hopefully it will be emailed out to you by your professors or put on campus. You have a paper copy already. Make sure for this test that you have a scientific calculator so that you can do problems such as this very first one very simply and get the correct answer, especially if you're not the best with adding, subtracting, multiplying, dividing, those kind of things, or if you're squaring something and so on. If you need any help on how to use your calculator, please come and see one of us at the lower level of the library and we can show you how. Now to get started with this, I'm going to show you how we will do this. We're just going to plug in -3 for x and we're receiving this function. So if I have 3 times -3 plus 7, this is what happens when I do f of -3. I just replace x with it everywhere I see it. So 3 times -3 is -9 plus 7, and -9 plus 7 is going to give me -2. Okay? Now, let's go ahead and do the second one. Same setup. So f of 5 is equal to 3, replace x with 5, plus 7. Okay? Now I do 3 times 5, which is 15, plus 7, which will give me 22. Now, going off of what you might have on your test, you might have something that has a square root. So let's repeat the first one, -3. We're going to plug that in. I'm going to change this problem just slightly. Instead of f of x is equal to 3x plus 7, let's make it 3x squared plus 7. And now I'm going to plug in -3, okay? So in this case, you have a calculator. This is really going to be a good way to see if your calculator is doing exponents properly. Depending on how you enter it into a calculator, it might not do it correctly, or your type of calculator by default might not do the problem correctly. You have to know which one you have so that you can regulate it, so you don't write down something wrong accidentally. So -3 squared is +9. So I have 3 times 9 plus 7. 3 times 9 is going to give me 27 plus 7. That will give me a final answer of 34. I just want to show you this just in case you have one that has an exponent on your actual test. Okay? Alright, let's move along to the next problem. Now this whole test, most of it's about graphing. Now my graphs on here are not going to look that great because I have these big pens and I'm writing with it. I don't have a ruler or anything to make sure that the perfect is straight. So you're doing yours are going to look a lot better than mine. The first one says, consider the graph of the line containing the given points. They want us to find the slope and graph it. Well, let's go ahead and graph it first. It doesn't really matter what order I'm doing it. So, as you know with points, it's x and y. So I go to the x first, which is here, and that's my y. So I go to -2, this is 0, and see, here's -2 at the bottom. Go to -2, and then I go up to 4 right there. That's the point A. Okay? Now, the point B is I go over here to the positive side, and I go to 5, is in between 4 and 6, and I go up to 4. That's the dot there. That's B. Now, the only line that can go through these 2 points is a horizontal line, okay, which has a 0 slope. So I'm going to draw my line by connecting my dots. And let's say that I didn't have a graph to do this with. I could still use my slope formula, which as far as I know you have to have memorized for this test, which is y2 minus y1 over x2 minus x1. And I would plug in my x1, y1, my x2, y2, and I would get 4 minus 4 over 5 minus -2. 4 minus 4 is going to give me 0. 5 minus -2 is going to be changed to a plus like that, and then that's going to be 7. It doesn't matter what's on bottom because this whole thing is 0, okay? But I can also see, because if you look at the graph, it's a horizontal line. Horizontal line automatically has a 0 slope, okay? And so here's the big clue here. I'm going to write 0 here. Look at this. Let's go back to our points. What do we notice? What is the same? If you have the same y value, in this case we do, the only line that can go through this point is a horizontal line. Now what if you had the opposite? What if you had the same x value, but different y? So if I had like, 3, 7 and 3, -2. In that case, I would have a vertical line. And which point would it go through? Well, the one that's the same, 3, okay? So make sure that if you had a vertical line, you know how to do the same thing with this type of problem, okay? All right, and then that would, of course, have an undefined slope, but not in this case. So this is this one. Make sure you know how to do that. Let's look at the next graph. Okay, the next graph is giving us a point and the slope, and it's asking us to find the equation of the line. Okay, and it doesn't give us any parameters. It doesn't say slope intercept. It doesn't say point slope. It'll show you both. Okay, you know, some teachers are having you do point slope, some aren't. So you should know by now which one your teacher is, if you're doing it or you're not doing it, so that you can get the answer to this problem right. So let's start with point slope. Okay. Usually you use the point slope formula, which is y minus y1 equals mx minus x1, to even get your answer in the slope intercept. Now, where is this x1 and y1 coming from? Oh, right here, the point, okay? And so I'm just going to plug those in. I'm going to plug an m. The x and the y here never change. They stay x and y. You got to have them. Otherwise, you won't have an equation, a whole bunch of numbers. It won't make any sense. So I'm going to have y minus negative 4 equals 3, my m, x minus 0. Now, your teacher says point slope. This is okay, except you have that minus minus. You need to fix that, make that a plus. So this is y plus 4 equals 3, x minus 0. So this is point slope. Your teacher said point slope. This is the answer they want. Don't go any further. Now, if your teacher said slope intercept, the other one, which is probably what you're used to seeing, you would stop here, and then you wouldn't stop here, I'm sorry, and you would take this even further. So to go to slope intercept, let's write this out. I would take this, how it is, and I would solve for y. So I have y plus 4 equals 3, x minus 0. So to solve for y, I'm going to distribute 3, and I get 3x, and well, 3 times 0 is 0. I don't even have to write anything. But if there was a number there, I would write minus whatever 3 times that number is. Now, bring down my other side. Here I'm going to minus the 4 and minus the 4. Now I can't combine the 3x and the 4. We should know that by now. So I get y equals 3x minus 4. Now in this case, this is the slope intercept, okay? This is the easier one to graph. This is the one that we like to graph because we have our slope, which is r3, and we have our y-intercept, which is 4. The default version of this is y equals mx plus b. M is your slope, as we all know. B is your y-intercept. Your y-intercept, int just for intercept, is where you start on the graph on the y-axis. So let's look at this graph real quick. We start on the y-axis at negative 4. My slope is going to tell me to go, I'm going to write it 3 over 1. You always write it as a fraction. If it's a whole number, it's already a fraction. You don't have to do anything. Because it's positive, I'm going to go up. And I always go to the right. I don't go to the left. Okay? Don't ever try to go to the left. So I'm going to go up 3 and over 1. I have to go over 1. If I don't, then this would be a vertical line. So let's see what's going on. Start at negative 4. We need to graph this, okay? So here's negative 4. Put a dot. Put a dot right there. My slope is 3, up 3, and over 1. So if I count up 3, 1, 2, 3. See, if I stop where I put this dot, if I stopped right there, and I tried connecting this like this, that is a line that has an undefined slope. This has a slope of 3. Any line that has a slope that's a number, whether it's a fraction or a whole number, like 3x or negative 2/3, it needs to have something like this, or maybe it needs to go in the other direction, going down, and, you know, don't write this down, I'm just looking at explaining this to you like this. Okay, it needs to have some kind of slope that would, you know, you're walking uphill or downhill to the graph. Okay, in this case, again, we started at negative 4 and I went up 3, 1, 2, 3, and over 1. That's my next point, okay? I only need 2 points to draw a graph, so I would connect my dots at this stage in time, and I would be finished. You draw arrows on the end to show that the line is going on. Some teachers really want you to extend your graph like this. I personally am not very big on that, as you can tell. But, you know, I've seen students who do this. Here's my 2 points, and then, oh, I'm done. No. Make sure that if you do a line and you're going to stop a little short like this, kind of go on a little bit, but you have the arrows. Of course, it's not going to be 100% correct. Still over here, okay? This, what I just did, was an actual line. My longer one, that was a line. But that little one that I just erased and I put the little arrows on, that one was not 100%, okay? So this is how you graph and slope intercept. Got to start at that 1 intercept and go up 3/1. If you're not sure, you might need to practice some. I'm going to stop this here, and then I'm going to do the next one in a new video.